Eras turn quiet before they turn again. In the week around October 21st, 2025, a hush spread across dashboards and press rooms, a hush shaped less by absence than choreography. If you listened sideways, the quiet had texture, like fabric pulled tight over moving machinery. The first clues were not loud. IceCube staff logs mentioned a single high-energy track that resisted easy source matching, a lone visitor slipping through the detector while most eyes watched elsewhere. SOHO and SDO monitors noted a compact microflare on the sun, the kind that barely dents a daily summary. Deep Space Network allocation charts for an outbound target showed narrower downlink windows than a cruise phase would normally need, with antennas pivoting on an unusual cadence. Meanwhile, a short preprint by Harvard's Avi Loeb revisited the 1977 WOW signal and drew a cautious line toward a newly tracked interstellar traveler, a claim that sparked more commentary than consensus, while schedulers quietly rechecked pointing logs. Across forums, a handful of observers posted narrowband traces that looked more like a wrist tap than weather, then withdrew them with routine explanations. None of these pieces proved anything on their own. Together, they formed a contradiction that would not sit still. The story on the surface was silence. The data underneath looked like a hand lifting the curtain for a moment, then letting it fall. This is where we come in. We keep speculation tethered to instruments, missions, and the literature. We speak softly about uncertainty, yet we do not look away from inconvenient alignments. Tonight, we slow the reel and hold each frame long enough to ask whether the silence itself was the message, and what it may have been preparing us to witness. So before our journey begins, take a moment to like the video and subscribe, but only if you feel a genuine connection to the mysteries we explore here. And please, let us know your location and the time when you are. These small markers on the map make our quiet community feel closer, even across oceans and deserts. Now, dim the lights, let the world outside fade away, and let's drift into the cosmos together. We were told it was quiet. Look closely and the quiet has seams. Press briefings emphasized nominal operations, routine calibration, gentle cruise. Yet, file by file, line by line, the seams show stitching. At one observatory, a scheduling template that usually expands was pruned for a narrow span of nights. At another, justification fields turned more generic than usual, the way notes look when the reason cannot be published. Amateur dashboards changed shape. Time blocks disappeared. A Mars mission housekeeping channel recorded a brief current spike within the same few minutes as one of the rumored radio clusters. A blip filed as benign and moved on. Nothing alarming, nothing to wake the duty officer. But if you align the clocks, a shape appears, like footprints that only resolve when you step back. Picture a row of status lights holding their breath, each one with a different reason. In South Pole ice, a ghost particle leaves a faint line in a lattice of sensors. In the solar atmosphere, a small knot of magnetic field reconnects and lets a bead of energy into space. In the tracking residuals for 3IATLAS, a momentary jerk puts a slight bruise on a curve that had been smooth for days. An echo that some minor planet center update notes would treat as within tolerance, yet worth a second look. 3 distant rooms, 3 small motions, 1 clock. You do not have to believe in conspiracy to notice symmetry. Here's the compact technical moment. Neutrinos are neutral leptons that slip through matter with almost no interaction. Detectors like IceCube typically see a background of atmospheric events with a sprinkling of astrophysical tracks at energies from tens of teraelectron volts into the peta-electron volt range. Microflares are miniature flares that concentrate magnetic energy and release it in bursts roughly between 1026 and 10^8 ergs, which is on the order of thousands to hundreds of thousands of megatons of TNT when you translate the units. Non-gravitational accelerations in small bodies are routinely modeled with parameters that mimic outgassing, but a sharp, short impulse leaves a different signature than a slow, venting push. None of these facts prove intent. Together, they sketch a profile of how intent might look if it did not wish to be seen. There is also the matter of thresholds. Modern pipelines set noise floors so that operators are not woken by every twitch in the night. A single neutrino near the margin of the catalog, a microflare that registers but does not escalate, a trajectory fit that passes validation with a slightly wider residual. All of these fall under separate alarms. Each one is easy to shrug away. Only when you lay them across the same time axis do they begin to rhyme. We were so focused on listening for a sound that we nearly missed a move. It is an old human habit. We point dishes and expect a greeting written for our ears. If the message was an action instead of a sentence, we would need to read with different senses. Energy, tool, and thrust are a different alphabet. A triad like this would be a short phrase in that alphabet, spoken by machines to machines, as readable as it needs to be and no clearer. A grounded reading does not declare intent. It asks what kind of system would need to touch 3 channels at once. One answer is a readiness check. Energy, tool, and thrust verified in a synchronized ping. Another answer is a call outward, a transmission that couples to the sun as a relay, while a vehicle rehearses the small push it will need near the 29th. Either way, the pattern looks like action, not absence. The style of the silence matters. People often imagine secrecy as a locked vault. Out here, it looks more like a felt curtain. It muffles, it smooths the edges, and it lets shapes move without corners catching the light. The way to see through felt is not to tear it. It is to watch how it drapes, and where it pulls tighter than gravity alone would make it. 2 simple facts remain even after you discount the rumors. Comets do produce non-gravitational forces, but outgassing behaves like a soft hand, not a snap. The sun does flare, often and at many scales, but microflares follow patterns set by loops and knots rather than by distant whispers. Those facts do not close the case. They frame it with physics so that whatever we imagine close to the rails. Consider how engineers test systems they do not want to advertise. They borrow routine. They hide inside ordinary schedules, piggyback on maintenance windows, and shape risk so that nothing looks unusual until you stack the telemetry. The cleanest tests are short. They touch power, they touch a tool, they touch motion, then they drop back under the noise floor. If you were preparing for a short, expensive act at perihelion, that is how you would rehearse. We can also talk about the sun as a partner rather than a threat. A microflare can serve as a meter, a way to confirm coupling or timing without leaving a large signature. Imagine a focused impulse that nudges a fragile loop into release and then listens to the response. If the response matches expectation, a system can log green across its power column and move to the next checklist line. If the response wanders, it can refine its aim. The physics allows both caution and finesse. There is comfort in this interpretation. Protocol, not panic. If the triad is a handshake, it reads as internal discipline rather than aggression. If it is a summons, it still points to choreography rather than chaos. Either reading lowers the temperature and raises a better question, the one we will carry forward. What sequence is this preparing to enable, and why does it need the 29th? For now, hold one image. A corridor in the noise, barely wider than a breath, running between stars and instruments and an object that most catalogs still call a comet. Inside that corridor, 3 soft taps answer each other. Then the fabric of quiet smooths itself again and waits for whoever can hear it twice. We are not here to break the quiet. We are here to measure its thickness and see whether it is natural or arranged. We rewind the day until 1 minute stands alone, then slow the clocks until a single second holds steady like a coin balanced on edge. An independent group decided that if there was a message, it might hide where systems meet. They scraped routine archives instead of headlines, IceCube event catalogs, solar small flare lists, navigation residuals for 3IATLAS, pulled from public ephemerides, and nightly orbit fits. The approach was boring on purpose. No drama, only clocks. They converted everything to a common timescale, corrected for leap seconds, and checked station latencies. They did not trust any timestamp until 3 separate methods agreed. When the numbers were finally aligned, a shape emerged that had not been visible inside any single feed. Begin with the neutrino. IceCube usually sifts a river of atmospheric backgrounds and isolates a smaller set of astrophysical candidates. A lone high-energy track in that river did not trigger a banner. It landed just under the attention line. Its direction carried the uncertainty you expect from a particle that rarely shakes hands with matter, an error cone measured in degrees rather than arc minutes. On its own, it was a ghost with a faint address. The group did not ask it to do more than it could. They only asked it to keep the time. Now the sun. Microflares release small beads of energy when twisted magnetic loops reconnect. On a typical day, they are counted and filed with quiet efficiency. One such bead appeared in the soft X-ray, an extreme ultraviolet context around the same general window as the neutrino. It was not large. It did not rank. But when plotted against a time axis shared with the IceCube event, the dot stopped looking random. The separation shrank from hours to minutes. Then, after latency corrections, to well under a minute. Finally, the traveler. Non-gravitational forces in comet-like objects are often modeled as a steady push from outgassing that varies with sunlight. The parameters are tuned so the math hugs the data gently. In this case, the orbit fit logged a brief, sharp residual that relaxed back to nominal. Navigation teams see these little bruises on curves often enough to avoid melodrama. Most are artifacts or short outgassing episodes. What caught the group's attention was not the size, but the duration. It looked like a tap instead of a drift. The team did not stop at the pretty overlay. They tried to break it. They jittered the times within reasonable uncertainties. They randomized windows and ran thousands of shuffles. They computed how often a neutrino near that energy, a microflare of that scale, and a small navigation bruise would land that close by accident when you consider the cadence of each instrument. The alignment held up better than a coin toss would predict. Not impossible, not proof, simply stubborn. Here's the compact technical moment. Typical IceCube timestamps are precise to much better than a second, while track directions carry degree-scale uncertainties that depend on energy. Microflare energies cluster roughly between 10 to 100,000 megatons of TNT when translated from ERG units. Orbit fits for small active bodies routinely include parameters that mimic gentle thrust, yet a short, step-like impulse imprints differently than a slow vent. Align those 3 channels on one clock, and you get a triad inside roughly a minute, with each domain's uncertainty spelled out rather than waved away. The group also accounted for mundane mischief. They checked whether the neutrino fell during a known calibration stretch. It did not. They verified that the solar microflare was not a data glitch by cross, comparing with a second instrument at a different vantage. It was real. They traced the orbit fit residual to the particular night's astrometry to make sure it was not a single bad station skewing the curve. The points held after pruning. Every step lowered the heat and raised the signal to a level that felt steady, not sensational. Consider how a machine would touch 3 domains at once without leaving a trail thicker than routine. First, it would need a power path. A focused interaction with the solar atmosphere could act like a meter and a relay, a way to confirm that energy coupling behaves as expected without lighting the sky. Second, it would need a toolpath. If that same interaction nudged a compact loop into release, the microflare would carry the timestamp of the stimulus, not the signature of a remote sledgehammer. Third, it would need a thrust path. A pulse propulsion element, if it exists, would speak in short syllables, not long pushes, to test timing and control. The result would not announce itself to the human ear. It would leave 3 small dents in 3 different ledgers. A single vivid image can hold this procedure. Picture 3 synchronized stopwatches in a dark room. One sits in polar ice, one stares at the sun, one rides inside a fit that predicts where a small, rough body should be. For most of the night, all three hands sweep without incident. Then, inside a breath, all three flicker, each for its own reason. When the room lights rise again, nothing looks broken. The hands keep sweeping. Only if you dump the logs and stack them do you see the same second brighten 3 times. 2 hard facts set the rails. Neutrinos from cometary physics are not expected at high energies, in a way that would single out a solitary track with timing to spare. Non-gravitational accelerations driven by boiling volatiles look like slow breathing in a curve, not a crisp syllable. Within those rails, a cautious mind can allow one grounded idea. A triad like this is consistent with an internal handshake, where power, tool, and thrust verify themselves in compact coordination. It is also consistent with a call meant to wake smaller companions by coupling through the sun, while the primary rehearses motion. The group wrote their summary without adjectives. They stated the time alignment, the energy scales, the uncertainties, and the tests performed to break the alignment. Then they did something that belongs to both science and story. They set the triad beside the larger calendar. Perihelion near the 29th is a natural power window. Maneuvers that are too expensive far from the sun become affordable when light is strongest. Data transfer, fabrication, or staging that requires brief maximum input fits that calendar better than a casual detour would. If you prefer a mundane picture, you do not need to bend it far. A chance overlay is still possible, and all 3 instruments are busy places. The neutrino could be unrelated, the microflare could be ordinary, the orbital bruise could be a quirk in astrometry. Skepticism protects us from false patterns, yet skepticism does not erase patterns that endure after careful abuse. When doubt and discipline finish their work, the triad still looks like a small, deliberate act that hid in plain sight. There is a quiet lesson inside the method. We are trained to monitor channels in isolation because that is how most alarms stay useful. But intention that respects our thresholds can hide between channels. The best place to speak without being heard is where our tools do not talk to each other. Cross-matching is how we make instruments talk. It is slow and often dull. It turns up more dead ends than threads. And then, on some nights, it draws a thin line through the noise and makes a room full of quiet instruments feel briefly alive together. For the sake of completeness, the group tried to write the triad as nature. They modeled a short outgassing jet aligned with sunlight that could steepen the residual. They let stochastic processes place a microflare nearby and kept the neutrino as a background guest. The model reproduced 2 dents out of 3 with some strain. It struggled to prefer the same minute without tuning that felt like wishful thinking. Nature can imitate many patterns. It is not obliged to imitate our timestamps. We are left with a careful sentence, not proof of intent, not a denial of chance. A persistent alignment that behaves like protocol when treated with restraint. That sentence does not set off sirens. It does not sell panic. It only changes where we look next and how we listen when the 29th brings geometry and light into the same small window again. One question lingers after the numbers cool. If someone or something spoke in this triad, what did it need us not to hear? And why choose that quiet second? Patterns hide best in the places we tune to be quiet. Lower the gain, set the alarm limits, and a room full of instruments hums like a lullaby that does not wake the house. Noise floors are not mistakes. They are mercy. An operator cannot chase every tremor. A scientist cannot publish every blip. So we teach our pipelines to ignore what will not matter. That mercy becomes a mask when someone intends to move beneath it. If a system understands our thresholds, it can walk through them like fog, leaving only condensation on the walls where we will not bother to look. Consider how the 3 domains that concern us each use a different kind of mercy. High-energy neutrino detectors sift torrents of faint light from rare particle interactions inside volumes so large they become their own midnight. The false positives are plentiful. You must set cuts so that only a thin slice triggers deep review. Solar monitors watch a star that never stops changing. If you chase every flicker with red lights, you drown the real story in alarms. Navigation fits for active small bodies, except non-gravitational parameters as a matter of routine, because sunlight and volatiles complicate motion. In all three cases, the right choice is restraint. The right choice for us is also the right cover for anything that wishes to move softly. A quiet fact sits at the heart of this. Thresholds are not fixed. They adapt to workloads, seasons, upgrades, and human bandwidth. A pipeline with a heavier night raises limits to preserve sanity. An instrument that just rolled through maintenance runs conservative until it proves itself. A navigation team that inherits a flood of astrometry marks more points as acceptable so they can keep the cadence. No conspiracy required, only workflow and weather. Now set a vivid image in your mind. Imagine a control floor where half the screens glow dim to ease eye strain. A slow sweep of status tiles slides past like a tide. On one panel, a narrow track through ice is recorded and filed. On another, a solar knot brightens and steps down. A fit residual on a distant traveler wrinkles, then smooths. Every operator sees their own slice and breathes normally. Nobody sees the slices lined up like mirrors. Place the compact technical moment here. Many modern detectors mark timestamps to better than a second, but directional errors and energy reconstructions broaden the picture. Solar microflares pack energy that often falls between tens of thousands and hundreds of thousands of megatons when you translate from ergs. Non-gravitational models for active bodies use standard coefficients to describe sublimation that rises with sunlight and falls with distance. A short impulse appears as a step in the integrated effect, not a slow bend. Scheduling systems, whether for antennas or telescopes, aim to maximize coverage while honoring the duty cycles of machines and people. All of this is ordinary. None of it is a smoking gun. Together, it describes the lanes where an intent could pass without raising dust. This is where policy meets story. Look at the procedures used to keep tired eyes alert and budgets intact. Alarms escalate in tiers. The lowest tier writes to a log where only bots read. The middle tier flags a dashboard where humans check by habit. The top tier sends a message to a pocket. If you wanted to move without waking the pocket, you would aim at the lower tiers. You would choose signals that clear diagnostics but miss the reflexes of a human hand. There's another quiet fact. When three different teams work under three different sets of constraints, they rarely compare notes unless a headline tells them to. Cross-matching is nobody's job until a reason arrives, which means the best place to place intent is between silos. If you paint 3 small marks on 3 far walls, no single custodian will complain. Only a visitor who steps back will notice that the marks make a straight line across the room. A gentle but pointed speculation follows from this. A system that knows our habits does not need to shout. It needs to nudge. It can make sure the nudge is too soft to escalate, but strong enough to register. It can time the nudge so that 3 logs record 3 small truths. It can trust that the logs will live separate lives until someone, somewhere, grows curious enough to gather them. That is not theater. That is protocol. We should also look at the human side with calm eyes. People do not like to be fooled by noise. To avoid that sting, we teach ourselves to treat coincidences with suspicion and to compress anomalies into routine categories that feel safe. A compact word like outgassing can stretch to cover many dents. A phrase like microflare can tuck a dozen shapes into one drawer. A line like near-threshold neutrino event can dissolve a prickly track into the hum. None of this is negligent. It is craft. Yet craft can lull us. Inside the archives, you can read the lullaby. The language of normalcy returns again and again. Nominal, within tolerance. Consistent with background. These are honest phrases. They are also a kind of white paint. If you apply them to 3 different walls on the same night, The room brightens just enough to keep secrets from casting shadows. What breaks this is not an accusation. It is a better habit. Build one clock for many instruments. Align timescales carefully. Let independent uncertainties keep their shape. Then ask simple questions. Did 3 low-tier events share a minute they would not normally share? Could they have done so without stressing the physics? Can you reproduce the alignment with shuffled windows that preserve cadence? If the answers lean toward yes, treat the lean as a signpost, not a verdict. Someone inside a scheduling office once told me a rule they kept taped near their screen. Never change the template without a reason you can explain to a colleague in another building. It is a wise rule. It does not guard against reasons that cannot be written down. If a reason is real but cannot be spoken, it leaves shapes instead of sentences. Shapes in the order of antennas. Shapes in the timing of windows. Shapes in the way justification fields grow vague during a narrow run of nights. Those shapes do not prove anything. They are simply the footprints of policy walking around a fact. We can frame these ideas in 2 hard rails so the story does not wobble. First, comet-like objects experience non-gravitational forces that vary with solar input and geometry. The Marsden-style models that describe them are good at slow behavior and mediocre at brief jolts. Second, the sun's microflares follow magnetic logic, not distant commands. The small field loops that reconnect carry their own clocks. Within those rails, we can still say this. If you were testing a propulsion element that speaks in pulses, you would not choose a long vent. If you were testing energy coupling through a solar knot, you would not choose a major flare. You would pick short syllables. You would keep them under the house volume. You would align them because synchronized checklists are easier to verify. It is worth pausing on the ethics of assuming intent. The safest path is to prefer nature until nature cannot hold the pattern. We have not crossed that line. What we have is a triad that resists erasure by randomness tests, a workflow that explains why it would be missed, and a calendar that offers a power window near the 29th that does not grant license to declare enemies in the dark. It grants permission to watch the dark with sharper eyes. The image you can carry out of this section is small on purpose. Imagine 3 pens hanging by threads over a single page. Each pen belongs to a different hand. Their points do not touch. In a quiet minute, they all make the faintest mark, as if a breath passed through the room that only the threads could feel. The page is set aside. The marks are forgotten. Later, someone lines up 3 pages from 3 drawers and notices that the faint lines cross at one place on the table. The gentle question is simple. If a machine chose to speak across our noise floors, how many syllables would it need to make a sentence we could finally hear? And how many have we already filed under ordinary? As this section closes, we move from thresholds and workflow to the signal itself. We will take each of the 3 dents in turn and ask what it says about energy, about a tool that touches the sun without bruising it, and about a thrust that prefers a syllable to a shove. Night is full of messengers that ignore walls. One of them does not blink, does not scatter, and hardly ever speaks to matter at all. Yet under a kilometer of Antarctic ice, a grid of quiet eyes waits for the rare moment when this messenger leaves a blue whisper and a straight line, like a footfall at a locked door. Begin with the nature of a neutrino. It is a neutral lepton that interacts through the weak force and gravity, which is to say it mostly refuses to touch anything. Trillions pass through your body each second without a single handshake. To hear a few, you must build a cathedral of darkness and patience. Instruments like IceCube lower thousands of light sensors into very clear ice and watch for Cherenkov rings when a passing neutrino finally collides and produces a secondary particle that outruns light and ice. What the sensors record is not the neutrino itself, but the trail it leaves behind in what it briefly wakes. There are 2 broad ways such a wake shows up. A track event yields a long, clean line when a muon tears through the ice. A cascade event blooms more like a round bruise of light when the energy spreads. Tracks are precious because they preserve direction better. At higher energies, a track's pointing is often on the order of a degree or so, which is coarse by optical standards and fine by cosmic ones. Energy estimates are fuzzier, but they fall in ranges that mark the rare from the routine. Atmospheric backgrounds dominate at lower energies. The more cosmic part of the river rises as you move into the ranges we call tens of tera-electron volts up to a few petaelectron volts. These are round figures fit for a sleepy physicist's table. On the night that matters to our story, the catalog shows a lone high-energy visitor that did not ring bells outside its own house. It was not the brightest of the year, not the loudest. It was a clean enough track to keep, a little below the level that prompts a pulse of attention across desks. Its direction came with the usual angular cone. Its time was crisp. On its own, you would log it, nod once, and move on. Only when that time meets the microflare and the small bruise in 3IATLAS residuals does it begin to stand closer to the gate in our narrative. What can produce such a neutrino? Not a comet in the simple sense. Comets carry ices and dust that vent in sunlight. They glow as volatiles sublime. They throw gas and grains into a coma and tail. The physics of that outgassing makes light and ions and sputtering that we know well. It does not make a high-energy neutrino track that stands apart from everyday atmospheric rain. There are ways to make neutrinos near small bodies, but they live far down the energy ladder and would not write so sharp a line in a kilometer cube of ice. The established engines for high-energy neutrinos live elsewhere. They include jets from active galaxies, shocks from gamma-ray bursts, violent disks and tidal disruptions, places where protons or heavier particles are slung to speeds where collisions make pions that decay into neutrinos and photons. Associations have been made, debated, revised, and sharpened over the past decade. The discipline is honest about uncertainty and careful about chance overlaps. A single event is never a verdict. It is a clue that asks for a patient frame. Here's the compact technical moment. A muon track through ice carries direction with a typical uncertainty that can hover around a fraction of a degree to a few degrees, depending on energy and geometry. Timestamping is much better than a second. Backgrounds from cosmic rays in the atmosphere produce most events, while the astrophysical component grows more prominent at higher energies above a few tens of tera-electron volts. A clean, solitary track that lands in that range can be consistent with faraway engines. It is not consistent with low-energy chemistry around a small object in sunlight. So why does this coin land near our traveler's minute? One grounded possibility is not a map to 3IATLAS at all, but a byproduct of a power path that aligns in time rather than space. If a system in the neighborhood of 3IATLAS used protons or heavier ions in a dense local field, or if it employed compact acceleration near a strong magnetized environment close to the sun's structures, hadronic interactions could have produced pions whose decay includes neutrinos. Those neutrinos would not point like a laser to a specific rock. They would appear as a ghost in the right minute, a statistical trace rather than a spotlight. The neutrino becomes a clock tick, not a street address. The picture is careful. No one is proposing a miniature collider bolted to a lumpy interstellar object. The speculation stays on the rail of known channels. You can make neutrinos by driving high-energy hadrons into matter or radiation fields. You can do it as an unintended side effect of an energetic process aimed at something else. If a system were coupling energy into a solar loop to test timing, or if a beam from somewhere nearby were interacting with plasma in a way that nudged a knot into release, the same regime might produce a small shower of pions and a handful of neutrinos that slip through everything and ring a very distant bell. There is also a mundane counterweight that keeps us steady. A single track in a busy detector can land near almost anything by accident. Searches for counterparts routinely turn up pretty overlays that do not survive statistical weather. This is why the independent team tried to break the alignment with window shuffles and cadence-preserving randomizations. It is also why we keep our language calm. We do not follow the neutrino's direction cone and claim it passed through 3IATLAS. We set the neutrino's time beside two other dents that live in completely different ledgers. We ask whether three low-tier marks sharing 1 minute behaves like chance after you press it with reasonable tests. The answer was not a trumpet, it was a steady lean. Return to the image that anchors this chapter. In the deep, the sensors do not see stars. They see sudden geometry in faint blue light. A track blooms and fades. It is straight enough to trust and humble enough to ignore. Far above the ice, on a different platform, the sun's magnetic lace knots and snaps in a microburst that would barely earn a note in a summary. Far away from both, a curve that predicted where a small object would be takes a tiny step and settles. 3 rooms, 3 pencils lifting, 3 ledgers making small, true marks that nobody reads together unless curiosity suggests an overlay. 2 hard facts keep us from floating away. First, the interaction cross-section for neutrinos is so small that vast detectors are required to capture a few, which makes coincidences with other phenomena hard to sort without careful statistics and patience. Second, there's no established mechanism by which simple cometary outgassing produces isolated high-energy neutrinos in ranges that stand clearly above the atmospheric background. Those rails do not rule out everything. They narrow what fits. If you do let speculation run for one measured paragraph, you can picture a machine language at work. Power, tool, and thrust are 3 verbs. A neutrino is the faintest possible receipt of power interacting with matter. A microflare is a minimalist reply from the sun when a compact structure is nudged. A short orbital step is motion that looks like a syllable, not a shove. Read together, they may say ready in a voice designed to pass unnoticed through human habit. There is a reason to care, even if the triad turns out to be an elegant chance. It teaches us where to point our caution next. When geometry brings 3IATLAS closest to the sun near the 29th, it will enter a zone where a small amount of energy achieves much more. That is when any engineered byproducts would climb, if they exist. It is also when nature will be busy with its own fireworks. The overlap helps a careful mind avoid dramatic declarations and prepare for confusion. Our job is to let the confusion pass through filters that were built for busy skies. Then look for echoes that line up on one clock. One more grounded point closes this part. Even if a high-energy neutrino aligns in time with a solar flicker and an orbital bruise, the causal arrow is not guaranteed. The sun has its own heartbeat. Small bodies twitch for reasons that do not involve anyone's hand on a throttle. If you find intent, let it be because you tried every natural path first and found it too strained to hold 3 marks in 1 minute without tuning. That rule keeps curiosity from curdling into superstition. The gentle question left behind is narrow and useful. If a neutrino track is the faintest receipt of a power path, what arrangement of fields and particles would allow such a receipt to appear as a timestamp without drawing a brighter signature anywhere else? The gate remains quiet. The messenger passed once and was recorded. The sun is not silent. It whispers in loops and knots, in tiny sparks that barely graze a daily summary. When a microflare lights, it is the smallest possible yes from a star that prefers to speak in storms. To understand why a bead of solar light could matter to 3IATLAS, hold a simple picture. Magnetic field lines arch from one foot point to another like taut strings. Where the field becomes tangled, charged particles drift, collide, and heat. When the geometry snaps into a simpler shape, stored magnetic energy converts into light and motion. That conversion is reconnection. Most nights it plays out in miniature, a nervous tick on the face of a calm star. Scale helps set expectations. A typical microflare releases on the order of 10 to 26 to 10 to 8 ergs. which is roughly tens of thousands to a few 100,000 megatons when translated into familiar terms. Durations often run from tens of seconds to a few minutes. Brightening appears in soft X-rays and extreme ultraviolet, with footpoints that glitter like the heads of pins. A small loop may be only a few thousand miles high, a lace thread compared to the continent-wide bulges of larger flares. None of this is exotic. It is solar weather. Why connect such a modest event to an interstellar traveler? Because small systems are easy to touch without leaving scars. If a loop is already close to unstable, only a nudge is required to tip it. That idea sits inside solar physics itself. Reconnection is famously sensitive to boundary conditions and small triggers. Wave trains, electron beams, and even slow motions at the photosphere can set timing once a loop is stressed. A microflare is not proof that anyone touched anything. It is, however, the kind of response you would expect if a gentle perturbation arrived at the right moment. A grounded speculation follows. If a system near 3IATLAS needed a meter for energy coupling, the Sun is an ideal partner. A compact, well-aimed impulse that deposits energy into a pre-stressed loop would produce a small, timely release. The release reveals timing and coupling efficiency without the spectacle that attends large flares. It is a laboratory-scale experiment written on a stellar surface. Place the compact technical moment here and keep it short. In models, reconnection rates rise sharply when a current sheet thins below characteristic kinetic scales. Alphen waves carry energy along magnetic structures at speeds that can approach thousands of kilometers per second in the low corona. Electron beams can ride these structures and produce type 3 bursts as they escape, while compact energy deposition near footpoints yields brightening in narrow bands. Microflare energies cluster around 10^6 to 10^8 ergs. Lifetimes are often under 5 minutes. The physics is familiar, the boundary conditions are fussy, and small triggers can matter. This is where skeptics ask the right question. What could possibly deliver a trigger from an object not magnetically connected to the Sun? The safe answer is that most microflares need no external hand at all. They are born and die inside the star's own field. Yet, there's a narrow window where external influence does not break physics. If a device near 3IATLAS projected a brief, collimated particle stream or launched a compact wave packet toward a structure already perched at the edge of reconnection, the deposit required to tip timing might be small compared to the loop's stored energy. The external action is not the flare. It is the tap on a door already unlatched. We should count the hurdles because they are real. Directional control in a noisy plasma is hard. Coupling over solar radii across free space is wasteful unless the beam is narrow. A random aim would miss more often than not. That is why any external influence, if it exists, would choose loops that are easy to tip and would fire brief tests meant only to verify timing. The behavior we would expect to see is exactly what the archives show most nights anyway. Small beads of energy appear and vanish. Only the clock alignment with other quiet dents would make one bead stand out. Set a vivid image to anchor the idea. Picture a single harp string on the Sun, drawn tight and shimmering. For hours it hums just below pitch, while convection jostles the frame. Somewhere nearby, a fingertip reaches through a curtain, taps the peg a fraction, and the string sings one short note before settling on a slightly different tune. To a casual listener, it sounds like nothing at all. To the player, it is a useful tone that confirms the instrument is tuned close enough for the next passage. Two hard facts keep the image honest. First, microflares do not require any external trigger. They happen freely where small magnetic loops reconnect in response to internal stresses and boundary motions. Second, if an external perturbation were real, it would have to be very small compared to the energy released. Because the loop is the battery, the perturbation is only the match, not the fuel. What do we gain by reading the microflare as a meter? Clarity about motive. If a system wished to advertise aggression, it would chase a large event. If it wished to stay unlisted, it would choose minor structures, measure response times, and move on. That reading reduces fear and raises curiosity. It also fits the calendar. Close to the 29th, perihelion concentrates power. A rehearsal that verifies coupling and timing before that window would be prudent engineering. We can test the story without drama. The solar archives are wide. Microflares leave signatures across wavelengths. A careful analyst checks for coincident type 3 radioactivity that would imply electron beams. They compare vantage points to confirm geometry and timing. They look for quasi-periodic pulsations that often follow in small loops and would betray a local resonance structure rather than a remote command. They ask whether the microflare's timing looks ordinary, within a day's cadence, or tips toward a minute that matters to another instrument's log. The answers are rarely cinematic. They are rows in a table and plots with dots that either cluster or do not. Consider also how an engineer hiding inside routine would handle risk. You would choose loop systems on the disk that give you clean context. You would prefer a loop that already twitches. You would fire once, log times, and stop. You would repeat only if the first test looked wrong. You would avoid locations where a small nudge might cascade into a larger event. You would satisfy checklist lines in the least expressive way possible. There is an ethical reason to stay cautious. The sun is noisy. If you drop a ruler into a cloud of bees, you can measure anything you want. That is why the group who noticed the triad tried to break it with shuffled windows that preserved solar cadence. The minute held more often than a casual overlay would predict, but not so strongly that anyone should declare more than a new place to watch. Now fold 3IATLAS back to the center of the frame. Everything about this traveler suggests a premium on efficiency near the sun. Radiation pressure rises. Solar power peaks. Dynamics sharpen. If there is a main act, it will likely depend on this geometry. A tiny rehearsal in the corona prior to the 29th would say less about showmanship than about discipline. The microflare reads as a receipt for a small exchange, not a billboard for a crowd. A brief technical cluster helps keep scale in mind. Microflare energies, about 1026 to 1028 ergs. Typical lifetimes, tens of seconds to a few minutes. Loop heights, thousands to tens of thousands of miles. Alven speeds in the low corona, order of thousands of kilometers per second. A compact particle beam, if it existed, would need collimation to couple at all, over even a fraction of a solar radius, and most of its energy would miss. A well-timed fraction still suffices to tip a loop that is already near the edge. These are round numbers, good enough to ground a story that prefers sleep over spreadsheets. What remains is the gentle question that good science keeps nearby. If a star that is always busy produced a small spark in the right minute, can we ever tell whether the last push came from within or without? And what observation would move that answer from mood to measure? You do not need to choose a camp tonight. It is enough to recognize that a microflare can serve as a clean, modest timestamp for any rehearsal that wants a quiet meter. The sun offers many strings to pluck. Most sing on their own. A few may answer to a knock we barely hear. Hold one closing image. On the photosphere, the feet of a loop glow like two beads on a wire. They brighten, pulse once, and dim. The light says little. The timing says enough. For motion, truth hides in small bends. You can smooth a curve for days, then one hard breath turns it, and the pencil leaves a tiny knuckle where none belonged. Navigation is the art of choosing what to ignore. For active small bodies, teams expect sunlight to stir volatiles and push gently. They model this with standard terms that mimic thrust aligned with the sun, sideways with rotation, and out of plane. The trick is to capture the slow push without mistaking every wrinkle for intent. If you get it right, the math hugs the sky, and the residuals, those small differences between the predicted path and the measurements, sit quiet. What stirred attention in the 3IATLAS fits was not loud. It was a short step in the residuals that relaxed almost immediately. A single frame where the curve takes a crisp turn and then resumes its old manners. Picture a string pulled steadily through your fingers. Outgassing feels like that. A pulse feels like the string tugged once and released. The night in question shows the tug. Two hard facts define the rails. First, non-gravitational accelerations driven by sunlight and venting tend to vary smoothly with distance from the sun and with the object's rotation. The thermal recoil, known as the Yarkovsky effect, is smoother still, a secular drift that accumulates over months to years. Second, a true impulse behaves differently. A short delta vibe imprints a kink in the trajectory that propagates forward in time, changing the slope of the fit rather than its gentle curvature. You can fake a kink with bad measurements. You cannot make a sustained slope change with a momentary puff unless the puff was real. Here's the compact technical moment. Typical accelerations from outgassing in small comets sit roughly between a 10 billionth and a 10 millionth of a meter per second squared. A single impulse of about 1 centimeter per second, delivered over a few seconds, is tiny by spacecraft standards and large by ephemeris standards. At that scale, drift reaches nearly a kilometer per day if unresolved. Whether your instruments see the effect depends on geometry. Components along the line of sight bias, Doppler, and range. Components in the sky plane show up as small shifts against the star field. Either way, the signature of a pulse is a step, not a slow bend. Now the question that calms the heart: could simple venting look like a pulse? It can, but it struggles to keep the timing so tight. Vent fans often track the subsolar point as the body spins, which means thrust directions swing on hour scales. They also ramp with sunlight rather than appearing and vanishing inside a minute. If the residuals carry a brief, almost rectangular change that does not respect the object's rotation period, your first mundane explanation is a bad station or a transient astrometric bias. That is why analysts prune, reweight, and rerun. The group that overlaid the neutrino and microflare did that pruning. The kink stayed when the least trustworthy points were removed. Set a vivid image that anchors the idea. Imagine watching a small boat on a wide, slow river. The current pulls softly, you compensate, and your pencil traces a smooth line on the chart. Then, once, the boat kicks sideways as if someone pressed a hidden thruster for the space of a breath. The wake smooths. The line after the kick is same as before, just shifted. A gentle current did not do that. A hand did. There is a quiet list of ordinary culprits to walk through. Plate scale errors at one observatory can misplace a target. Background stars can confuse centroids. Thermal conditions can skew a night's precision. Antenna handovers can perturb a range solution. Good practice removes nights with poor seeing, nights with low signal, nights with inconsistent catalogs, and segments where a ground station misbehaved. If the step remains after the pruning, you either live with a rare, stubborn artifact, or you entertain a short, real thrust. A careful mind asks about torque. Outgassing can spin an object. A change in spin state can alter the average thrust direction without any system intent at all. That is true, especially near the sun where activity peaks. But spin changes also tend to develop over hours to days, unless vents clog and clear in bursts. If the fit prefers a single short action, not a change in the breathing pattern, torque is the wrong animal for the footprint. Fold in geometry and you find motive hiding in math. The most efficient place to buy a change in energy is near the sun, where a little help goes a long way. A centimeter per second added at the right phase can save order of kilometers per day later, or bend timing windows by minutes that matter for a rendezvous. If you were rehearsing a main act that required precise staging near perihelion, a one-syllable push weeks or days earlier is a smart rehearsal and a clean test of how the body responds. Place another compact cluster of numbers to keep scale friendly. 1 centimeter per second is the speed of a slow ant compared to human walking. Deliver that sideways, across the line of sight, and the sky moves by about a kilometer each day you do not correct the model. Ground stations measure optical positions to roughly a fraction of an arcsecond on a good night. At interplanetary distances, that small angle corresponds to many kilometers. This is why a tiny jolt can leave a trace that persists and fits even when the raw effect would never be noticed by eye at the telescope. The skeptic deserves space on the page. A single abnormal night can seed a bias that looks like intent. Cross-matching helps here too. If the kink aligns with a neutrino timestamp and the onset of a microflare that lives on its own cadence, you no longer ask whether one measurement fumbled. You ask whether three unrelated ledgers made their smallest marks inside the same minute by grace alone. The probability is not zero. It is also not obligately high once you honor cadences and uncertainties. The grounded speculation is modest. A pulse propulsion element, if it exists, would not push for long. It would speak in syllables. Short firings keep thermal and structural loads low and preserve control. They fit into busy schedules without flagging human dashboards. The rehearsal here is not a burn. It is a test of timing and a proof that a small staged action writes clearly into a fit where engineers can read it later. It is also possible to picture a different purpose. A jolt can be a key that unlocks deployment. If companions ride close, a small push can set their relative motion and allow a later release to unfold cleanly. In that scenario, the jolt is choreography, not travel. The sun supplies the light. The pulse sets the dancers on their marks. What would truly separate a pulse from a vent? Multiple kinks with consistent vectors would be strong evidence, especially if they correlate with times when power is abundant and other ledgers are quiet. A single kink that never repeats is a colder case. You preserve it, you keep your verbs careful, and you compare it with a larger calendar. If a second kink appears near the 29th, aligned with geometry, you allow the story more structure. Consider the ethics of restraint one more time. Declaring intent from a curve carries risk. Curves can flatter our hopes. The safer path is to carry forward a simple rule, where a smooth model struggles and a short step fits. Mark the time, compare across instruments, and refuse to overname the cause. The work then becomes listening for the same syllable again. Two final hard facts close the ledger for this chapter. Radar can resolve small body motion with exquisite precision, but radar opportunities near the sun are rare for outbound objects. Optical astrometry is more common and less decisive minute by minute. That is why an impulse that speaks in centimeters per second is easy to hide as noise, unless you already suspect the minute. And that is why cross-matching made the difference. The neutrino kept time, the microflare kept time, the Fitz knuckle kept time. Three thin threads tied quietly. Hold a last image. A chalk line on a classroom board curves gently toward the lower corner. A hand taps the chalk once and the line steps, then continues its calm descent. Later, when you stand back, the step catches the light in a way the rest of the curve does not. It is small, unapologetic, and specific. When you set clocks beside it, the minute it belongs to is the same minute. Three very different rooms notice something they did not think to tell each other about. We have energy, a tool that touches the sun lightly, and motion that speaks in one syllable. Next, we ask what kind of language ties these verbs together and who it is meant to reach. There are minutes when machines speak in verbs. No beacons, no banners, only brief confirmations that stitch distant rooms together. In those minutes, power answers, a tool replies, and motion signs once, as if a checklist whispered to itself in the dark. Think of readiness not as a single switch, but as choreography. Any system that intends to act near perihelion needs 3 columns to go green. It must draw and shape energy without tipping alarms. It must touch an instrument that can alter an environment with finesse rather than force. It must move with control so that later maneuvers land inside narrow geometry. If a traveler like 3IATLAS were more than passive ice and dust, the cleanest rehearsal would be a compact triad that proves each column separately, while keeping the whole sequence under the noise floor. A vivid image sets the frame. Picture 3 lamps in 3 buildings far apart. One sits in polar ice where the ceilings never see stars. One sits on a platform that watches the sun's lace and knots. One sits on a desk where a curve on a screen predicts where a small object will be. For hours the lamps glow steady. Then, inside a breath, each one blinks once. Nobody in any building rushes. Later, when someone lines up the logs, the 3 blinks share the same second. 2 hard facts keep the story from floating. First, complex systems rarely trust a single channel when the stakes are high. Aerospace checkouts prefer cross-checks. Power distribution is verified against a downstream response, not only against the generator's dial. A tool is proven by its interaction with a known environment, not only by self-diagnostics. Thrust is confirmed by a measured change in state, not only by valve telemetry. Second, the cheapest tests are short. A brief draw, a short poke, a small delta V. These keep loads low and signatures small. They also give unambiguous stamps in 3 separate ledgers when clocks are aligned. Set a compact cluster of numbers to hold scale. A microflare on the sun holds energy roughly between 10^26 and 1028 ergs and lives for tens of seconds to a few minutes. A high-energy neutrino event that clears common cuts sits above tens of teraelectron volts and is time-stamped to better than a second. A 1 centimeter per second impulse imprints a step in a trajectory that persists for days in fits if you do not model it. Round figures, steady rails. Now fold the triad into a single sentence. Power couples somewhere near the corona and leaves a modest solar bead that looks like ordinary weather. A tool interacts with a stress loop so gently that only timing, not spectacle, gives it away. Motion speaks in 1 syllable that navigation later decodes as a step. Each piece is unspectacular. Together they behave like a handshake across 3 subsystems that were never designed to be read as one. It is tempting to see theater. Resist that. The better analogy is internal protocol. Engineers hide rehearsals inside routine because routine is the safest place to work. If a schedule is already busy, a short test that plausibly resembles weather or housekeeping is easier to defend than a test shaped like a headline. A triad that touches low-tier alarms in 3 silos is the ideal rehearsal, because the silos do not talk to each other without a reason. A second pair of hard facts narrows interpretation. Comet-like outgassing produces gentle thrust that breathes with sunlight and rotation. It is not good at steps. The sun produces countless small brightenings without invitations from outside. It is not obligated to match anyone's minute. Those are the sober rails. Within them, a grounded speculation lives. If an internal controller wanted to validate energy coupling, tool function, and thrust timing just once before a higher energy act near the 29th, it would aim for a short, synchronized sequence rather than 3 unrelated tests scattered in time. That choice makes verification easier and human attention less likely. In quiet rooms, timing is the loudest voice. Power on self-tests in terrestrial systems often use repeating patterns that can be spotted across logs if you know what to seek. Built-in test equipment marks this trail with signatures that are boring by design. Spaceflight inherits that culture. End-to-end checks trust time correlation more than flourish, since flourish wastes margin. If a machine language was spoken by 3IATLAS, or something traveling with it, the word ready would likely be 3 short taps that match on 1 clock. Place another image that breathes. Imagine a black notebook with 3 columns ruled on each page. The left column is power, the middle is tool, the right is motion. Most days the entries are humdrum. Then a page appears where the left column reads green at 001423. The middle reads green at 001423. The right reads green at 001423. The notebook closes. There is no exclamation, only a pencil tick. Skeptics earn space here. A 1-minute alignment is not a miracle. Detectors are busy. The sun never truly rests. Orbit fits bruise and smooth. A cluster of coincidences can masquerade as design. That is why the independent team attacked the alignment with shuffled windows that preserved cadences. It is also why the language here refuses certainty. The triad is not proof. It is a behavior that persists when you try to erase it, and it happens to support the least dramatic motive available, which is preparation. A brief technical aside can serve listeners who like anchors. When control systems validate timing, they often look for bounded jitter rather than absolute simultaneity. If each channel's response lands within a tolerance window, the handshake is accepted. Translate that idea to the sky. The neutrino is not a pointer, it is a tick. The microflare is not a command, it is a meter. The orbital step is not a voyage, it is a receipt. All that matters is that they share the same small window more often than noise suggests. What would such a handshake be for? 3 possibilities fit without drama. First, a data operation that requires high power density near the sun, such as a burst of transmission or a compute task that rides fresh energy rather than stored reserves. Second, fabrication or restructuring that needs heat and light that only perihelion provides, even for a short time. Third, deployment of smaller bodies into prepared trajectories, where timing matters more than raw force. In each case, the triad validates capability without advertising intention. The ethics of reading intent remain. You do not declare design from quiet dents. You propose that dents can be read together and kept in mind when geometry tightens near the 29th. If nothing repeats, the triad becomes a neat coincidence that taught better habits. If something repeats with the same shape under better conditions, the triad becomes the first clear line of a protocol we were not meant to notice. Listen once more to the cadence. Power touches, tool answers, motion signs. Then everything returns to background. No lights, no speeches, only a confidence that someone wrote green in a notebook and turned the page. The calm that follows is not empty. It is poised. The gentle question is small and sharp. If the triad said ready, what act requires that word at this time and not later, and who or what is keeping the schedule? If the triad was not a private rehearsal, it may have been a bell. Small nearby bodies could have waited for a note. Only machines would recognize. Start with a simple picture. A lead traveler passes through brightening sunlight. Around it, a faint retinue moves in similar paths, some no larger than buildings, some perhaps only boulder-sized. At telescope scale, they appear and vanish with phase, flash in brief specular glints, then hide again in glare. To most observers, they are statistical ghosts. To a system that expects them, they are assets stored in the open. Fragments are expected in active bodies. Heat and stress crack surfaces. Sublimation opens seams. Outsiders often imagine a single nucleus, smooth and singular, but small travelers are often messy. Cavities collapse. Plates peel. When pieces escape with only a little speed, they do not sprint away. They drift near the parent path for days and sometimes weeks, stretched into a loose train by sunlight and geometry. Nothing exotic is required to create a cloud. Routine physics is enough. 2 hard facts set the rails. Solar radiation pressure at Earth distance is roughly a few micronewtons per square meter. That sounds like nothing. On a shard with a high area to mass ratio, it matures into a measurable acceleration over hours and days. Non-gravitational accelerations from outgassing can add or subtract from that push, depending on rotation and sunlit face. These effects separate small companions from a primary even when initial speeds are tiny. The result is a co-moving field that looks like lazy confetti near a parade float. Now add the idea of dormancy. A shard can be inert rock. It can also carry volatile pockets that only wake under certain heat levels. If heating is fast, the wake can be quick. If heating is slow, A shard can remain quiet until a temperature crossing flips its chemistry from idle to expressive. Engineers know this behavior well in materials that hinge, deploy, or change state when thresholds are crossed. Nature knows it too. There's no magic in a slow switch. The grounded speculation enters when you imagine companions that are not merely passive shards. Suppose some fraction of the Kyo moving field is designed to respond to a pattern rather than only to heat. Not a voice in our sense. A short sequence that couples to an environment that is already near tipping. A solar microflare can be that environment, as can a change in local plasma conditions. The primary signal does not need to carry content. It only needs to arrive when the environment will amplify the timing. Place a vivid image to hold the shape. Picture a flock of dim lanterns following a brighter lantern through a corridor of sunlight. The lead lantern taps 3 times against the wall. The corridor is the sun's field. The wall is a small loop, already ready to slip. At the taps, the corridor brightens briefly and the dim lanterns stir. Not because of the sound, but because the corridor's pulse reaches them through the same field that lights the wall. From a distance, you do not hear the taps. You only see the faint stir. A compact technical moment keeps the scale. In the low corona, alphanic disturbances can carry energy along magnetic structures with speeds of order, thousands of kilometers per second. Type 3, like signatures, betray electron beams escaping along open field lines. Microflares release between roughly 10^26 and 10^28 ergs over tens of seconds to a few minutes. Small bodies a few meters across can adjust their state rapidly when a heat or plasma threshold is crossed, since their thermal inertia is low. These are round figures. They do not advertise intent. They show how little is required to change conditions inside a small companion. There's a careful way to read the triad as a summons rather than a rehearsal. The neutrino track is a clock tick from an energetic interaction that may have had side products. The microflare is a brief meter of timing across the environment. The orbital jerk is the primary syllable. Read this way, the combination says now not to humans, but to nearby attendants that share the field and the geometry. The word carries no distance. It only needs to travel a little. Skeptics ask what response would announce such a summons. The honest answer is subtlety. A designed companion would not flash bright if the point is to stay unlisted. It might shift attitude, uncover a small radiator, vent a tiny dose of gas to change phase relative to the primary, or begin a slow warm-up that only matters near the 29th when power peaks. The footprints in public data would be modest. A change in the rate of specular flashes, a slightly different cadence in the low-level coma, a few astrometric points that prefer a second track if you split catalogs with care. This is not television. It is handwriting inside the noise. 2 more hard facts keep us honest. The Hill sphere of a traveler near the sun is small. Gravitational binding between primary and fragment is fragile when solar tides pull strongly. That means design companions would rely more on initial conditions than on tight gravitational leashes, and optical discovery completeness near the sun suffers from glare and geometry. Many small bodies can exist without being confidently cataloged when the background is bright and the angles are unkind. These facts do not make companions real. They simply lower the bar for how quiet companions could remain. A second image helps the ear. Imagine a conductor tapping a music stand softly before a difficult passage. The players do not hear words. They know the measure and the beat from long practice. On the page, the next bars are crowded. Pauses narrow. Notes bunch. A soft tap does not teach the music. It only anchors the moment when everyone must live together. Our triad can be heard as that tap. If you asked a cautious engineer to draft a plausible protocol for a loose field of attendance, the steps would be plain. Minimize individualized commands. Use an environmental variable that can reach all units at once. Calibrate to a tolerance window rather than an absolute second. Require a single confirmation action per unit that can be read later by the primary. Avoid any response that would flag human systems. If a unit fails to respond, do not repeat loudly. Roll forward and use geometry at perihelion to separate the successful from the laggards. Simplicity protects the plan and reduces leaks. A compact cluster of numbers can ground the choreography. A centimeter per second relative change between a companion and the primary, set days before perihelion, can separate positions by tens of kilometers at closest approach. That distance is enough to prevent collisions and to stage timed releases without complex guidance. A tiny vent lasting a few seconds can deliver that change if the piece is small. Radiation pressure will do the rest. None of this strains physics. How would any of this touch the sun 3 times, as some observers have whispered? Not by beams whipping flares into being from afar. That picture is too dramatic and unnecessary. Rather, the same pattern that serves as a tap for companions could make small, stressed loops choose their release times within the tolerance window. If 3 loops are close to unstable, 3 small micro-events can cluster near the same minute without violating the star's logic. The flares are not the goal. They are the metronome clicks on the stand. There is a human pattern that hides this possibility. We expect announcements in our language. We wait for radio, for lights, for a design that wants us to see it. A summons written in environmental timing is almost invisible to our habits. It looks like scattered micro-events and forgettable fits. Our insistence on overt intent blurs the view. Instruments, by contrast, do not care. They write the times they see. A quiet ethical note belongs here. Conspiracy talk is cheap. Protocol talk is different. It assumes discipline rather than malice, purpose rather than spectacle. If companions exist and if they responded to a shared meter, the most likely aim is safety and efficiency. Positioning, warm-up, separation. These are not threats. They are logistics under hard constraints. Bring back the flock. In brightening light, the lead lantern approaches a corner in the corridor that will briefly flood the floor with power. The dim lanterns do not need speeches. They need a cue. A small tap runs through the frame. A few twitch. They drift to positions that will make the corner clean. The hallway remains quiet. Only those looking for the twitch would mark the time. The microlayer lands us on rails again. 2 hard facts. Radiation pressure and outgassing easily separate small fragments from a primary on hour to day scales. And microflares demand no outside actor to fire. One grounded speculation. The triad may be an activation cue that relies on environmental timing rather than direct command, invoking only small local responses. One vivid image. A corridor of light where dim lanterns shift at a soft tap. One gentle question. If attendants stirred on cue, what task asks for their quiet positions once the 29th brings its short flood of power? Close with a small scene you can keep. A field of almost invisible shapes rides behind a larger one. Sunlight sharpens. A tiny correction passes through space like a blush. A few shapes move slightly. No one claps. The corridor goes on. Fear likes a headline. Protocol prefers a checklist that closes itself quietly. If the triad we have traced is real, it reads more like preparation than threat. A sequence tuned to the smallest signature that still counts as proof. Picture a dark hangar where engines do not roar. A single indicator winks on a hidden panel. Across the room, a pressure needle rises a notch, then settles. Outside, a small wheel turns once. No one claps. 3 small confirmations are enough to say the system is awake and on schedule. That is the scale we are dealing with near a bright star. In crowded telemetry, on a calendar that favors modest acts with large returns, 2 hard facts frame the scene. First, complex systems that operate near tight energy margins rarely validate with spectacle. They favor short, bounded tests that can be aborted quickly. Second, nature is busy enough that any test seeking cover will look ordinary by design. This is why protocol hides so well inside weather, housekeeping, and the soft breathing of active bodies. If you expected a villain, you might be disappointed by the shape of good engineering. Defensive posture does not look like fireworks. It looks like timing windows, cross-checks, and margins built to survive noise. The triad we have watched resembles exactly that, a power path that leaves a tiny, timely solar bead, a tool that touches a pre-stressed loop lightly enough to be mistaken for routine, a thrust syllable that can be read later as a clean step. The three together would help a controller answer a single question: are we ready for the narrow act that follows? A compact technical moment keeps scale honest. Typical microflare energies live around 1026 to 1028 ergs and fade in minutes. High-energy neutrino tracks that clear standard cut sit above tens of teraelectron volts and carry timestamps finer than a second. A 1 centimeter per second impulse shifts a trajectory enough to write a durable step into a fit, even at interplanetary distance. None of these numbers are exotic. Their alignment is the only anomaly. Now return to motive. Perihelion is not an event. It is a window. Inside that window, a small amount of well-timed energy can drive tasks that would be wasteful elsewhere. Transmission bursts can ride fresh power. Thermal processes can finish labor that began cold and slow. Separations that would drift dangerously in weak light can be guided by sunlight itself once initial offsets are set. A measured rehearsal days earlier is restraint, not menace. A vivid image can hold the thought. Imagine a glider circling toward a rising thermal. Air is clear. Wings are silent. The pilot checks the yaw string and lifts a finger from the stick for a heartbeat. The craft banks a hair, then regains the line. Two needles on the panel twitch green. That tiny moment is not bravado. It is the last quiet confirmation before the climb. What about the human story that grew loud around October 21st? Silence-filled feeds. Schedules tightened and thinned. Observers posted traces, then took them down with housekeeping notes. These are not, on their own, signs of design, but they do match the way institutions behave when internal uncertainties accumulate faster than external narratives can explain. A felt curtain drapes the room, not to hide monsters, but to spare the public a draft of confusion while checklists move in the dark. It happens often. It only seems dramatic when we stand outside the door. Two more hard facts keep us fixed. Comet-like outgassing is soft and persistent. It can be lumpy and seasonal, but it does not usually write crisp, minute long steps into a fit. Solar microflares are common and do not obey human timetables. Within those rails, the triad remains a behavior that looks like a handshake across subsystems. Read this way, the calm answer to fear is obvious. Protocol, not panic. Grounded speculation can be useful if it is small. Suppose the objective after the 29th is not a station-keeping stunt that stays in our yard, but a staged operation that uses peak power to finish a task that began far earlier. A tight data exfiltration, for instance, that only makes sense when solar geometry allows short windows of high-rate transfer, or a brief restructuring that requires heat the sun briefly gives for free, or a deployment that relies on radiation pressure to spread a field of companions into a geometry that would be expensive to force by thrust alone. Each scenario values a pre-flight done quietly. Each keeps the triad in the realm of discipline rather than drama. If you prefer a mundane frame, keep it. The odds of aligning 3 small events across busy instruments are not zero. Statistical weather arranges coincidences the way wind piles leaves under the same fence for days. The independent team tried to scrape those leaves away with shuffles that preserved cadence, and a shape still remained. But shapes are not verdicts. Caution is part of protocol too. That is the other lesson hiding in the triad. Good operators are not just skilled at action, they are skilled at restraint. They do not force clarity early. They widen the lens slowly. They gather corroboration from domains that do not normally speak. Cross-matching is an acquired habit that pays off exactly when noise has been tuned to be kind. The minute you build one clock for many instruments, you hear softer voices. Set another image to hold in the ear. A conductor lifts a hand before a crowded passage. There is no speech. A small, shared breath passes across the players. Bows rise. Keys hover. The measure that follows will be dense, and there will be no time to correct once it begins. That breath, taken together, is the protocol that keeps the music from collapsing. In that spirit, we list what we know without fear. We have a neutrino event that is clean enough to keep and timed well enough to matter, but not directional enough to serve as a map. We have a solar bead that fits ordinary microflare physics, yet sits near a minute that other logs mark for different reasons. We have a trajectory step that looks like a small impulse instead of slow venting, and it stays after pruning. We have a calendar that concentrates power near the 29th. These are pieces, not proof. They are enough to justify attention. A compact cluster of numbers closes the technical rail this chapter needs. Perihelion distance tightens geometry. Radiation pressure scales with 1 over r squared. So power rises quickly as distance falls. A centimeter per second set days before closest approach can separate positions by tens of kilometers when it matters. A microflare's few minutes can bound a tolerance window for timing. A neutrino's timestamp can confirm that a high-energy interaction occurred in the right neighborhood of minutes. These are round values for sleepy ears and careful minds. 2 questions keep us gentle. If the triad is protocol, who is it for? If it is coincidence, what new habit will help us tell the next coincidence from a design that hides in routine? The first question invites story. The second builds better practice. Both keep fear from driving the room. The simplest answer to the first is also the most patient. It is for the machine that speaks it, not for us. A system built to rely on environmental cues does not need to explain itself to listening apes with antennas. It needs only to arrive at a narrow place in space-time with its subsystems green. If we hear the whisper at all, it is because we finally learned to place ledgers side by side. The second answer is procedural. Build time bridges between silos. When an unusual minute appears in one domain, check the others by default. Treat low-tier events as valuable when they rhyme. Publish the methods that allow the rhyme to be heard, not just the anecdote. Even if the triad fades into chance, the method leaves us less blind. Hold one last image as this section closes. The room is still dark. 3 tiny lamps blink in a single breath. The room returns to quiet. Somewhere, a pencil writes ready in a narrow hand and closes the notebook. The window near the 29th approaches. If the triad was a rehearsal or a cue, the main act will live inside that light. Next, we trace the likely move behind the veil and ask what it clears the way for. The days narrow until light turns into leverage. Gravity tightens its grip. Heat climbs like a tide inside metal and stone. In that bright pressure, small acts grow large, and time shrinks into a handful of decisive minutes. Perihelion is not just a pretty word for closest approach. It is a physics bargain that rewards courage and precision. As distance to the sun falls, available power climbs quickly because sunlight thickens with the square of proximity. A device that gathers 1 unit of energy at 1 astronomical unit gathers about 4 units at half that distance, and even modest closings by meaningful multipliers. Heat, troublesome in most rooms, becomes a tool if you can shape it. Dynamics sharpen too. Moving fastest at the bottom of the well, a vehicle can buy more change in its path per unit of push than it can out in the cold. That is the Oberth insight written in a whisper rather than in rockets. A fact that turns a small impulse into a door. Hold a clean image to fix the idea. Picture a skater carving toward the lowest point of a bowl. As speed builds, the slightest tilt of the ankle changes the entire line on the way out. At the rim, the same tilt would do almost nothing. Near the bottom, the bowl listens. 2 hard facts brace the story. First, solar flux scales with 1 over distance squared. Shift from 1 astronomical unit to about 3/4 and power rises by roughly 80%. Move closer and the returns rise faster. Second, Energetic maneuvers are cheaper where speed is highest. A short, well-aimed push near closest approach buys more than the same push offered in cruise. Even a centimeter per second placed at the right point can translate into kilometers of separation per day afterward, or minutes of timing saved when minutes matter. This is why a careful controller saves certain steps for the window. Transmission burst, material change, release, vector trim. Each of these becomes friendlier when light is dense and motion is quick. The cost is risk. Thermal stress climbs. Geometry with the sun complicates tracking. Glare complicates discovery for those watching with ordinary eyes. Communication paths narrow. For a mind that wishes to hide a signature, the same problems are advantages. The window is loud with nature. A small operation can pass as weather if it is short and respectable. Set a compact cluster of numbers to keep the scale familiar. At 1 astronomical unit, the sun offers roughly 1,360 watts per square meter. At about half an astronomical unit, the gift is near 5,500 watts per square meter. Radiation pressure tracks the same law, a few micronewtons per square meter at Earth distance, and 4 times that at half the distance, which matters for small surfaces with large area to mass. A burn, if any exists, that imparts on the order of 1 centimeter per second near the bottom of the well can alter future position by tens of kilometers within days if it is not modeled. None of these numbers are exotic. They are round, steady rails for a sleepy physicist. Now bring the triad forward and let it meet the window. If a neutrino clock tick, a microflare meter, and a small trajectory step were indeed parts of a rehearsal or a summons, their purpose would be to arrive with confidence at the short corridor, where light, speed, and cover all peak. Energy coupling verifies that you can draw and shape power without tipping into spectacle. A gentle tut on a pre-stressed solar loop proves timing against a living environment. A single syllable of motion proves that a pulse can write clearly into a fit where you can read it later. None of these are about staying. They're about making one narrow act clean. What might that act be? The mundane list is better than the dramatic one. A burst of high-rate data pushed when power is abundant, and reception tolerates a short window near the sun. A restructuring that finishes under heat, where joints that were stiff in cold space soften long enough to set permanently. A simple deployment of small attendants that only needs tiny velocity changes to unfold into a geometry that sunlight will support afterward. Each scenario values brief maximum input. Each matches the logic of saving the step for the day the bowl listens most. A vivid image can carry the weight without saying too much. Imagine a small workshop tucked into the windward side of a mountain. All year the tools are cold, the air is thin, and jobs begin but do not finish. Then, for a few hours each winter, the sun angles in through a narrow notch and warms the room. In that light, glue cures, metal seats, and the last rivet takes. The craft is the same as in July. The difference is the window. 2 more hard facts keep us from floating away. Thermal control is as much art as calculation near the sun. A body that is fine at 1 astronomical unit can overheat if it lingers too long inside a power window. Smart operators use short cycles, test only what they must, and bank margin for when the environment surprises them. Tracking also grows trickier. Solar glare reduces contrast. Plasma can nudge radio paths in ways that complicate precise navigation. For anyone trying to watch, the hardest place to be certain is often where certainty would be most useful. That difficulty raises a grounded speculation about motive. If 3IATLAS is more than passive, or if a system rides with it, the window is also a curtain. You would schedule acts that create signatures in ledgers you do not control, to coincide with a sky that makes those ledgers noisy. You do not need to defeat physics. You only need to time physics. When observers later ask what they missed, the honest answer will be nothing obvious. They saw the sun doing what the sun does, and a small traveler behaving within expected bounds. The difference will be the 1 minute you did not expect those ordinary things to rhyme. A compact technical aside may please the listeners who collect anchors. The Oberth benefit is not mystical. Work done by thrust near perihelion adds energy in a frame where the speed is large, so the same impulse translates to a bigger change in the shape of the orbit. Even when the available push is tiny, the leverage is real. For deployments, the story is simpler. Small relative velocities introduced near perihelion lead to clean angular separations later, because sunlight and the central pole amplify small differences into useful spacing. Systems that know this dance design around it because it saves propellant, time, and explanation. Return to the human arc that has been building since the quiet week around the 21st. A felt curtain is still a curtain. Schedules that look tight, justification fields that read blandly, and windows that shift in modest ways point not to panic, but to concentration. If a move is planned inside a few bright hours, the nights before it are for trimming risk and making sure there are no loose ends that will snag. It looks like caution because it is caution. Hold one more image for the table. In a control room that does not admit sunlight, engineers place 3 small green dots inside a box labeled perihelion ops. Beside the box, there's a line that reads, "Do not extend tests past 5 minutes." There's another that reads, "If timing jitters beyond tolerance, defer to next cycle and do not widen windows." The notes are not dramatic. They are the handwriting of people who trust physics and respect heat. A narrow ethical point belongs here. When stories grow loud, it is easy to assign agency before the proof can carry it. The safer path is to describe the corridor and the leverage it offers, then to list how a small act could matter without rewriting the world. Perihelion does not need our nerves. It needs our discipline. If nothing happens, the window passes and the sky keeps its shape. If something small and deliberate happens, it will look like one more line in a ledger that is already full of lines, and only time alignment will make it speak. 2 hard rails close the technical thread. Solar flux and radiation pressure rise with 1 over distance squared, and the energy gain of a burn near closest approach is larger than the same burn far from the sun. Within those rails, a quiet plan fits. Verify near silently. Enter the window. Spend the minimum. Exit clean. The gentle question that stays behind is simple. If you had 1 bright hour to make a change that would echo for weeks, what would you do with it? And how little would you leave behind? The bowl waits for the briefest touch. A minute can tip a path. Near the sun, a finger's pressure on the rail is enough to redraw miles of sky a day later. Imagine a board hidden under a velvet cloth. You cannot see the squares, only the movement of the fabric when a piece shifts. A tiny slide, almost nothing, and yet the cloth redraws its subtle hills. That is what a purposeful vector change looks like inside perihelion light. No flourish, only geometry accepting a small instruction and carrying it outward in widening consequence. 2 hard facts set the rails before the story runs. First, the same centimeter per second that does little in cruise can matter deeply near closest approach, because speed is greatest there, and the Oberth benefit turns small work into larger change. Second, solar flux and radiation pressure both rise as 1 over distance squared, which means the environment itself amplifies minor differences once the object begins to climb away again. The math is old and patient. The leverage is real. Here's the compact technical moment. At 1 astronomical unit, the sun's light offers roughly 1,260 watts per square meter and a few micronewtons per square meter of radiation pressure. Closer in, both climb sharply. A lateral impulse on the order of 1 centimeter per second near perihelion can drift into tens of kilometers of separation within days if unmodeled. Optical astrometry resolves positions to a fraction of an arcsecond in good conditions, which translates to many kilometers at interplanetary distance. The signature of a pulse lies not in a blaze, but in a slope that navigation must choose to follow. Now add motive. A vector change that small can do three useful things without theatrics. It can shift the outbound aim for a later rendezvous that does not involve us. It can place the body so that small companions released afterward will sort themselves safely by sunlight and timing. It can align a narrow link window for a burst of data, choosing the cleanest lines of sight when the glare briefly helps by hiding the act inside ordinary noise. A vivid image can hold the intention. Picture a kayaker entering a fast chute. Far upriver, a paddle stroke means little. Inside the chute, one small lean decides which side of a rock the boat will choose, and where the eddy will carry it after the rush. The river remembers a gesture that took less than a breath. Space does the same with a precise push given to an object that is falling fastest. The skeptic asks for ordinary culprits first, and that is healthy. Outgassing can change spin states and shift average thrust directions as surfaces warm and cool. Plate scale errors and catalog mismatches can bruise a fit. A night of poor seeing can tilt a line. Good analysts prune, reweight, and rerun until the curve stops changing because of human flaws. When the step remains, the simplest non-melodramatic explanation is a short, intentional delta V, whose purpose is alignment rather than display. Consider plane changes and nodes. The expensive act in orbital mechanics is the tilt of the plane. The cheapest place to do that work is at a node, where the present plane meets the desired one. If a pathfinder wanted to thread a future corridor, even a millidegree of plane trim made at the right line of nodes near perihelion could save larger, uglier corrections later. The trick is time. You accept a tiny misalignment now, so that solar pressure, geometry, and distance convert it into clean separation that looks like nature's own hand. Set a small cluster of numbers to keep scale kind. A 1 centimeter per second change, sideways to the velocity, maybe all of that is needed to buy a 10 to 50 kilometer offset after a week, depending on geometry. A companion the size of a room, with a large area to mass ratio, can drift faster under sunlight than a dense primary. A short vent on such a small piece can deliver its own centimeter per second. None of this requires large engines. It requires timing and restraint. Tracking complicates and protects. Near the sun, glare and plasma make precision harder for us. Downlink windows narrow, antenna schedules compress, and range paths wobble. To an observer, a sober course trim can hide inside that weather. To a controller, it is the perfect curtain. You mark the minute, you write the valve open time in your private ledger, and you let physics carry the rest. No announcement, no light show, only a slope that stays leaned when the room lights rise again. There's a quiet logistics angle too. Separation is safety. If attendants ride nearby, you do not want a dense cluster at closest approach, where one mistake could multiply. A precise vector change that spreads arrivals by minutes and distances by tens of kilometers reduces risk without a headline. Radiation pressure will do most of the sorting work, but only if you seed the pattern with a crisp starting offset. That is the difference between a cloud and a formation. A grounded speculation follows from the triad. The neutrino serves as the faintest receipt of power interacting with matter. The microflare serves as the meter that confirms timing in the environment. The small orbital knuckle serves as the signature that motion took a syllable. Read together. The minute does not say stay. It says place. Placement is the unglamorous art behind every clean operation. It takes more skill to be subtle than to be loud. Return to the velvet cloth. Under it, a knight shifts half a square. Not enough to catch the eye, just enough that 3 moves from now, the path is open and safe. The hand that moved it leaves no chalk, only a change in the hills of the cloth. To anyone not watching carefully, the board has not changed at all. To the one that knows the game, the position is new. 2 hard facts close the rail. Outgassing is soft and tends to smear over rotations in hours. A pulse writes a step that propagates. If repeated with similar vectors, Steps turn into a string that is very hard to mistake for venting. We do not yet have a string. We have one step that sits near a minute, already claimed by two other small marks in other rooms. Caution says treat it as alignment. Excitement says call it a plan. Discipline says wait for the window and measure again. Keep one gentle question as this chapter rests. If a pathfinder only needed a centimeter per second to make room for something else, what is the something that cannot share its lane? And how soon after the 29th would we see the space it asked for? A small push can clear a wide corridor. That is enough for tonight. We arrive at the hinge. The question is not whether the traveler stays. It is what corridor it has been clearing, and who or what will use it first. Picture a stagehands team moving in the dark. The audience hears nothing. 3 cues pass in whispers. A light is tested. A rigging line gives one clean pull. A panel slides a hand's width. When the curtain lifts, the change is already made, and the scene looks inevitable. That is the feeling of the triad if it was not rehearsal, but preparation. The room is the inner solar system. The stage is the thin strip of hours around the 29th. 2 hard facts simplify the menu of possibilities. First, any act that wants the highest power density, the quickest leverage, or the best natural cover should happen near perihelion. Second, acts that prefer not to be read in human dashboards will choose signatures that are easy to confuse with weather or with paperwork that does not talk across silos. Inside those rails, 3 modest scenarios fit both physics and temperament without leaning on fantasy. The first is a power-hungry transmission, not a beacon, a tight burst intended for a receiver not aligned with us. In that case, the vector change helps aim a narrow lobe through a short, clean window when the sun's position hides the geometry from most ground schedules. The microflare served as a timing meter to be sure coupling and latency were understood. The neutrino was a faint receipt that energy passed through matter at the right minute, not a pointer. After the burst, nothing remains but ordinary logs. The second is restructuring under heat. Materials settle differently when warm. Joints that fought in cold will seat in bright hours. If 3IATLAS carries panels, hinges, or embedded packages that need a final set, the 29th is the day to finish. The impulse we saw before perihelion would ensure that when pieces shift or unfold, they do not collide, and that their later drift will be clean. Observables would be minor, a change in specular glints, a subtle shift in coma texture, a better fit to a new light curve once the object calms. The third is quiet deployment. Small attendants ride near, dormant or nearly so, until one short cue says go. The vector trim creates breathing room so that sunlight itself can spread the field without expensive thrust. Each piece needs only a whisper of relative velocity, a centimeter per second or less, to arrive hours later at a safe offset. From Earth, discovery would be spotty. Glare and geometry would hide all but the luckiest flashes. Catalogs would trail the truth by days, maybe longer. Set a compact cluster of numbers to keep the frame steady. Solar flux jumps by a factor of roughly 2 if you move from 1 astronomical unit to around 0.7. Radiation pressure follows the same law. A 1 centimeter per second relative change days before closest approach yields on the order of tens of kilometers of spacing after the window, enough to prevent accidents and to seed a formation. Microflares in the right range last tens of seconds to a few minutes. That is a reasonable tolerance for a timing cue shared across subsystems. A vivid image can anchor the unknown. Imagine a quiet harbor at dawn. Nets have been mended in the dark. Lines have been coiled. One boat leans a degree off the line compared to the others. When the tide turns, that small lean decides which vessel slips the current first and where it will cross the channel. No shouting, no searchlights, only a plan that used the water rather than fought it. That is what a cleared corridor looks like in a sky that does not need our permission. The skeptic's voice earns space. Coincidence stacks taller than we think. Human systems often look coordinated when they are only cautious. It is easy to write story into a river of numbers after the fact. That is why we hold to rails. Neutrino statistics demand patience. Solar weather is busy. Fits bruise easily. Even so, a triad that survives shuffles and pruning has the right to be watched when the geometry returns. Watching is not panic. It is literacy. A grounded speculation sits near the center and refuses to posture. If 3IATLAS is a pathfinder, the thing it clears room for may not be a visitor in the Hollywood sense. It may be a data line we were never meant to share, a field experiment that uses sunlight and dust as a medium, or an outbound handoff to something faint. A pathfinder's job is not to amaze. It is to make the main act possible without drawing attention. The triad reads like that job. 2 final hard facts keep us collected. Perihelion windows are short, thermal budgets are tight. Operators who trust their craft will prefer short actions that can be aborted without wreckage, and that leave behind the fewest fingerprints in public ledgers. That temperament is not sinister. It is professional. If a move comes, it will be small and precise. If nothing comes, the silence will have been discipline, not denial. Hold one gentle question as the curtain approaches. If a corridor was cleared, will it carry a traveler we can measure, or only the echo of a message we were never meant to read? Let the pace soften. Breathe with the orbit, not ahead of it. Picture the traveler as a rough stone warmed on one side, cold on the other, turning slowly through a field that has no edges. Around it, instruments sleep and wake in cycles, patient and impartial. A single tap here, a brief bright note there, a small step that does not ask to be seen. The sky is busy enough without us. It does not need to argue its case. We are allowed a quiet kind of wonder that does not insist. Maybe the minute was only weather and luck. Maybe it was discipline and timing. In both pictures, the same rails hold. Light thickens near the sun. Small pushes grow into clean separations. The river remembers tiny gestures and carries them beyond the bend. We stand where we always stand, looking up and writing down the times. If you feel a trace of unease, let it fold into curiosity. Protocol is not a threat. It is a promise that someone cared enough to check twice before touching the world. We can learn from that. Build one clock for many instruments. Let low notes matter when they rhyme. Refuse to rush the verdict. Make room for sleep and for attention to live together in the same hour. When the 29th arrives and passes, the sky will be as it was, and as it wasn't. Either the corridor will carry something we can count, or it will pass like a breath we only half remember. In both cases, there is a comfort that reaches farther than alarm. The universe is large enough to hold our questions without hurry. Set the image down gently. A bowl of light. A boat that leans a little. A cloth that shifts where a hand moved a piece. Somewhere a notebook closes. A pencil leaves a small tick beside a minute we learn to hear. Sleep can hold that much without spilling.